done the topic of sampling with the large samples, and the difference of means were done in the yesterday's class. And today we are going to start with testing of significance for small samples under the heading of a probability or sampling distribution. So let us start our class today. This is the testing of significance small samples. That means we should have small samples. So this is we have to do today. This is testing of significance or small samples. There are different tests which we have to apply. There is a Z test or a student T distribution test. And the degree of freedom is very important in this heading. So we have a question straight away, and it will be very much clear from the question that we have a random sample of size 16. Size of the sample is 16. When we say that we are taking small sample, then the size should be less than 30. So this is size of 16, and it has a mean. Mean is given to us. Sorry, the sample mean is given to us. That is 53. The sum of the squares of deviation from the mean. This is the term we have. This term is known as the sum of the squares of the deviation from the mean. This value is given to us, and this value is 135. The question is, can this sample be regarded as taken from the population having 56 as mean? So mean of the population is 56. We are saying that, can we say that this sample has been taken with this mean and mean deviation from the mean? This value is taken from a population with mean 56. This is our question. And the second part of the question is, we just need to obtain 91st, 95% confidence limits and 99% confidence limits. So this is question number 1, and this will be question number part number 2 of this question. So we have to take a null hypothesis that the population mean is 56. Means to say that this sample has been taken from the population which has a mean 56, and its alternate hypothesis that the population mean is not 56. Either it is greater than 56 or it is less than 56. So greater than 56 or mu is less than 56. So clearly this is a question of a two-tailed test. Now you can apply a very important distribution, that is a T distribution. So apply T test, and the formula is, we just note down the formula, that is x bar minus mu over x upon square root n. So you can calculate the value of s. The value of s will be calculated by using this formula, x minus x bar square over n minus 1 square root. You can substitute the value, that is 135 given to us. And what is n? 16. So 16 minus 1 is 15, and you could be able to find out the square root, because it comes out to be 9. So the square root of 9 is 6. So the value of s has been calculated over here. This is substitute the values. This term also is 53 minus 56 over 3 upon square root of 60. So ultimately the calculated value of t is minus 4. Because we have made the negative sign, therefore the absolute value is 4. Now in the small samples, we have a very important term that is a degree of freedom. This is a very important term which will be used in the small sample. Degree of freedom is generally denoted by mu, and it is always equal to n minus 1. So in this case, that is 16 minus 1 is 15. So this is very important term which we shall use in this distribution solving question. Now we need to find out the table value. Table value of P at 5% level of significance for 15 degree of freedom, or 15 degree of freedom. So 15 degree of freedom, we just need to find out by using the table. And the table, P table, or you can say that the table for P distribution is given at the last of the book for two tails. You just check at the 5% level of significance, the value at 15 degree of freedom is 2.13. This is the value we have. Now, you know that the calculated value of P is plus 4. So P calculated is greater than P tabulated. So if calculated value is greater than tabulated value, as we know, we have used in the previous lectures also that in that case, null hypothesis is rejected. Therefore, H naught is rejected. If H naught is rejected, then clearly H1 is accepted. And if H1 is accepted, it shows that the sample has not come from the population with the mean of 56. It has been taken from some other population. So this is the final conclusion of question part number 1. So for calculating part number 2, we must use the formula for confidence limit, that is x bar plus minus s upon square root n into p 0.05. This is the formula, and this is the formula for 95% confidence limit, because we are using 5% plus. And the formula for 99% confidence limit will be x bar plus minus s over square root of n p 0.01. This is for 99% confidence limit. And substitute the values now. After substituting the values, the x bar is 53, and it is plus minus s come out to be 3 over square root of 16. The value of t at 5% level of significance for 15 degree of freedom is 2.1. From the table we shall use, and the values come out to be 51.41 and 54.51. These are the values, and after substituting this, this is 53 plus minus 3 over square root of 16. And the value from the table comes out to be 2.95 at 1% level of significance, and the values come out to be 50.79. This will be for negative sign, and the second value will be 51.21. This will be for positive sign. So these are the lower limit, upper limit, lower limit, upper limit. So 95% confidence limits are there, and 99% confidence limits are there. So this is the way by which we can apply T distribution. Now one more question is, this is the question in which we need to compute mean deviations from the mean. And the question is, the 9 items of a sample have the following values. These are the values we have. X is 45, 47, 50, 52, 48, 47, 49, and 53, 51. These are the values we have. And does the mean of these values differ significantly from the assumed mean? Assumed mean is 47.5. So this is given to us, differ from assumed mean. Assumed mean, you can say that this is the null hypothesis that the mean of the population is 47.5. And it is clear that it has 9 items, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the sample size is 9. Clearly it is a small sample. Alternative hypothesis can be mentioned, which is not equal to 47.5. Now you can find out the sum of this, and if sum of this goes for 2, you can easily check, and you can calculate the average of this sample, that is sigma x upon n, and it is 442 over 9, and that will be 49 times 1 after calculating the average, and you can find out the mean deviation from the mean value, because we need to calculate x, and for calculating x we have this formula x minus x
हेलो
square.
सर।
Yes,
सर आपकी आवाज बहुत कम आ रही है।
मेरी आवाज कम आ रही है?
यस सर।
अभी अभी कितनी आ रही है?
नो सर।
बिल्कुल नहीं आ रही?
सर थोड़ी थोड़ी आ रही है।
नहीं मतलब रुक जाती है बीच में?
सर रुकती तो नहीं है सर, बहुत कम आती है आवाज। सर मेरे पास ईयरफोन्स नहीं है तो इसलिए अच्छे सुनता भी नहीं।
सर बहुत
अभी
धीरे आ रही है सर, बहुत
अभी सुन रहा है?
धीरे।
सर
यस
बाकी
सर।
सबकी आ रही है, आपकी नहीं सुनाई दे रही है अच्छे से।
हेलो हेलो।
यस सर अब आ रही है।
वो उसमें लाइट चली गई एक्चुअली कंप्यूटर पर ना, तो इसलिए मुझे मोबाइल पर ज्वाइन करना पड़ा। नहीं तो आवाज सभी को नहीं आ रही थी प्रियंक?
सर बहुत कम आती है
यस
सर,
सर।
तो सर मैंने लैपटॉप पे किया था तो उससे मेरे को अच्छे से आ रही थी, बट सभी को नहीं आ रही थी सर आवाज। सर काफी कम आवाज आती
अच्छा
है सर।
लैपटॉप पर। ओके ओके, चलिए कोई बात नहीं। मैं ऐसा करता हूँ, मोबाइल साथ में अटैच कर लेंगे फिर अब आवाज के लिए ना। अभी लाइट आने दीजिए, फिर वो उसी से ही काम बनेगा ना। ठीक है। Are you here?
Yes, sir.
अब आवाज आ रही है?
Yes, sir.
ओके है?
ओके है?
आवाज क्लियर आ
आवाज
रही है?
क्लियर आ रही है?
So,
हाँ जी बेटे।
हाँ जी बेटे।
yes, sir.
वो
क्वेश्चन यहाँ से रेज हो गया, दोबारा से करना पड़ेगा। This was your question that 9 items were there. 45, 7, 50, 52, 48, 47, 49, 53, and 51. And the average has been
Sir.
calculated, that is 49.11. And your null hypothesis was mu is equal to 47.5. And alternative is mu is not equal to 47.5. Actually, what we want to do, we want
Hello,
to
sir.
calculate
Excuse me, sir.
Yes,
अरे
yes.
स्क्रीन
Yes, sir,
नहीं शो
screen-
हो रही है.
अच्छा, स्क्रीन नहीं आ रही है?
No, sir.
Yes, sir.
वो मैं प्रेजेंट करना भूल गया। अब देखिए,
Yes, sir.
ठीक है?
This
This was your formula which we have to apply. So for finding out S, we need to do this. This was your mean deviation from the mean. We will be able to calculate, and then we should have x minus x bar square. And it come out to be minus 4.1, minus 4.1, 0.9, 2.9, 1.1, 2.1, 0.1, this is 3.9, and this is 1.9. And the square of this term will be 16.81, 4.41, 0.81, and 8.41, and 1.21, and 4.41, and 0.01, 15.21, and 3.61. So it's a total we require here, and its total is calculated as 54.89, and it is divisible by 8 because sample size is 9 and is 9 here. So if this value come out to be 2.619. Now, as we always require for calculating t-test or applying t-test, and your t-statistic is x bar minus mu over s over square root n. And that will be 49.1 and 47.5, and it is 2.619 divisible by 9 square root. So the calculated value of t come out to be 1.832, and t at 5% level of significance for 8 degree of freedom, because the sample size is 9. So degree of freedom, so we require n minus 1. So 9 minus 1 is 8. And from the table, this value is 2.31. And clearly, the calculated value is less than table value, and it means the null hypothesis is accepted. And the null hypothesis accepted means, therefore, there is no significant difference. There is no significant difference between their means. Between the means of sample and population. So this is the question of acceptance, and last was the question of rejection. And this is the application part of t-test or t-distribution. So by this way, we can apply t-test Now this is the t-test for a single sample.
Next,
Next we shall apply t-test for two samples. The two samples will be a small sample. For this, we shall have a question. The two samples have been given. And, it is given that the sample size of first is 8 and the sample size of second is 7. And the sample mean, first sample mean is 1234 and the second sample mean 1036. Standard deviation S1 is 36 and the standard deviation S2 is 40. This is given to us. They are asking. Obviously, these two samples. This is sample number 1 and this is sample number 2. Obviously, this has been taken to a population, but the question is different. They are asking that is the difference in the means significant to generate that type 1 is superior to type 2. This is they are saying. Type 1 is superior to type 2 regarding their length of life. This is actually a sample of bulbs. And bulbs, this is the average life of a bulb. 1, 2, 3, 4 hour and 1036. Standard deviation is 36 hour and 40 hours. Now, there is the t-test, but this t-test is a little difference. That is x1 bar minus x2 bar, and it is divisible by that is s square root of 1 over n1 plus 1 over n. This is the formula we have to apply. This is a capital S. This one is capital S. Please write it in capital form. This is a capital S we have. And, we don't have the value of capital S. We have the value of x1 bar, x2 bar is there, n1 is there, n2 is there, but we don't know the value of S. So for finding out the value of S, we have another formula, that is n1 s1 square plus n2 s2 square, and it is divisible by n1 plus n2 minus 2, and it's square. So by applying this formula, you will be able to calculate the value of capital S, and it comes out to be 40.7317. This is your work, you will evaluate this one. After substituting the values, this is the 1036 and it is divisible by 40.7317 and it is the square root of 1 over 8 plus 1 over 7. So you will be able to find out the value of T, and it comes out to 18.148. This is your T calculated. Earlier, we have done the question of a single sample, but this is the question of a two samples. So for this, we should calculate the tabulated value according to the two samples. So it is important to calculate degree of freedom. Degree of freedom will be calculated by this formula, n1 plus n2 minus 2. So it comes out to be 8 plus 7 minus 2 is 13. So 13 is the degree of freedom. Level of significance is not given, so you can assume that this is at 5% level of significance. So T at 5% for 13 degree of freedom. From the table, you will be able to see that. And this value is 1.77. So T calculated is greater than T tabulated. Tabulated means table value. So if calculated value is greater than the table value, it means your null hypothesis is rejected. So H0 is rejected. But if H0 is rejected, it means H1 is accepted. inverse of that. And we should suppose what is H1 naught. H naught according to the statement, they are saying that their types, two types of bulbs have same life. Either mu1 is equal to mu2. They have a same life, but alternative will be they don't have same life. Average life of the two types of bulb, type 1 and type 2 is different. Clearly, in our case, H1 is accepted only. It means the bulbs have different average life. So you can conclude in writing that the average life span of two types of bulbs is different. So this is the final conclusion, and this is the case of two samples. One more thing. Suppose the question comes for two samples with data. In that case, we need to calculate S in a different way. Let us do one more question. We have two samples X and Y. I can do it over here. So just write down the values of X. X are 63, 65, 68, 69, 71, and 72. And Y has values 61, 62, 65, 66, 69, 70, 71, 72, 73. Clearly, it has a different size. N1 is different, and N1 is 6 here, and N2 is 9. You can count the values. And, they are saying that these are the heights of 6 randomly chosen sailors. These are the two samples of sailors. Sailors of sample with size 6 is given, and sailors of sample with the size 9 is given. And, they are saying that the test whether the sailors are on the average taller than the sailors on this side. You can remove the sailors here. You can take the soldiers, so that we will have different names. These are the soldiers, these are the sailors. And what they are saying that test whether the sailors are on the average taller than soldier. This is they have asked the question. So obviously we will take the population. The average height of sailors is mu1 and average height of soldiers is mu2. H1, H0 is they are not different. They have the same height, but clearly H1 will be accordingly to the statement. They are saying that sailors are taller. It means mu1 is greater than mu2. We have to take, and this is a single tail test. This is a question of one tail or single tail. One tail test will be taken. Now, for this, for applying the test statistic T, we should have average x bar minus y bar and S under 1 over n1 plus 1 over n2. All we have the values. N1 is there 6, N2 is there, that is 9, and we should calculate what is S and what is x bar y bar. X bar y bar can easily be calculated, that is sigma x over n1, and it come out to be 68, and capital Y is come out to be sigma y over n2, and it come out to be 67.66. The question is we need S, and for finding out S we should apply the formula Okay. We should apply the formula, but before applying the formula, we require mean deviations from the mean. So x minus x bar and x minus x bar whole square we require. Similarly, y minus y bar and y minus y bar whole square we require. We have done in the previous question. Previous question we have done in this way. So you can calculate these values and you will be able to find out S square. And the formula for calculating S is under root of 1 over n1 plus n2 minus 2. And inside this is a sigma x minus x bar whole square plus sigma y minus y bar whole square. So this is we need to substitute. N1 is there, N2 is there. So you will be able to find out S, that is 4.038. You can use the calculator here and calculate the value of population standard deviation, that is capital S. After this, you can substitute the value. The value will be substituted over here. This is T is equal to 68 and 67.66, which is divisible by 4.038 and under root of 1 over 6 plus 1 over 9. On an average, you can calculate that is 0.3031. So this is your T calculated. Now you need to find T tabulated. T tabulated for degree of freedom. Degree of freedom is n1 plus n2 minus 2 is equal to 6 plus 9, 15 minus 2, 13 degree of freedom at. This is a single tail test. At level of significance must be there, but no level of significance is given. So you just need to calculate the value at 5% level of significance. So at 5% level of significance for 13 degree of freedom, this value is 1.7. Now, T calculated value, this one, is clearly less than T table value. So if calculated value is less than table value, then null hypothesis will always be accepted. And the null hypothesis accepted means there is no significant difference between the heights of the sailors and soldiers. It means to say that their average height is same. So this is the way to check the difference of the means of two populations. This is the sample taken from first population, and this is the sample taken from second population. Which population we are taking? Sailors and soldiers. These are two different populations, and two different samples have been taken. So this is another common question in which we have to apply the t-test. After applying the t-test, we have another important test, that is Snedeker's F-test. We shall do questions related to Snedeker's in the next class, and it is also a very important test, but formula is little different. All these tests are depending upon formulas. To say that all the questions are based upon formulas. Formulas is there, and if you know the formula, you will be able to evaluate the significance level or distribution according to the test perspective.
Thank you very much.
Thank you very much.